Sec 1 Chapter 8, Part 1A Ratio. Now, in this part of the chapter, we'll learn about the concepts of ratio. That means understanding that ratio is actually a comparison between two quantities that are of the same units. Okay, and then after that, we also learn how to relate ratio to fractions so that we can try to form equations and solve for the unknown. Now, let's begin with our lesson. So before we begin with our lesson, you need this part of the notes. Now we are at chapter 9. Oh no, cancel away chapter 9 to become chapter 8, ratio, rate and speed. So we're going to understand about the concepts of a ratio, and your screen might look a little bit different from mine because I changed the format to fit into the screen. So, but we're still using the same worksheet. Okay, now please take a look at the following here changes. Please change this to 8.1a and 8.1b and so on and so forth. Alright, we shall begin with more details. Now, what is a ratio? A ratio is a comparison of two quantities that are measured in the same units. Okay, so what we can compare, for example, time with time, volume with volume, area with area, length with length, so on and so forth. But they should be all converted to the same units. However, after conversion and completing the answers, you'll find that a ratio itself has no units. Okay, and the ratio of A and B can be written as A is to B, or it can be written as a fraction A over B. And we have some examples of equivalent ratios. For example, let's say 1:2 can be the same as 2:4, or maybe it also can be the same as 50/100. Okay, or many other examples, okay, that you can think of. Now, let's get into action. You must understand that in order to find a ratio, there is a ratio of two integers. There should not be decimal involved in each of the ratios. So, look at our first question, example 1. Are these two numbers 13:39? Are they already in integer form? Yes, right? But now the next thing you need to check is, can we simplify the ratio? Is there any common factor between these two numbers? I have 13:39. Now what we can do is, we can try to actually use our fraction in the calculator format. You can try to key 13/39. What does your calculator gives you? Your calculator gives you 1:3, right? So that means this ratio can be simplified by dividing both sides by the ratio by the number 13, and I get the ratio 1:3. So this is how I actually use the calculator to help me to get to the answers. Alright, so what about 24:42? What are the common factors? 24 can be divided by 6, 42 can be divided by 6. Okay, if not, I can actually press 24/42 in my calculator, and the calculator shows me is 4/7. So that means in this case, I can actually have this one divided by 6 on both sides, and I'll simplify my ratio to be 4:7. How about 1.8 and 0.4? Well, my first instinct is to change this into whole numbers. I'm not going to like decimal places. So I can either use my calculator to help me and get an answer directly. Okay, if you can't, you can try to put 1.8 over 0.4 and see what does your calculator gives you. So according to my calculator, it gives me an improper fraction. It gives me a mixed number. I can change it to an improper fraction to give me 9:2. So according to my calculator, if I press this, I'll get something like 9/2 improper fraction. In this case, mixed number is not going to help because we want one integer over the other integer. So like a fraction form, but improper fraction. So, but how do I go about doing it if I do not have the calculator? So what I can do is, the first thing, I like to remove away the decimal places over here. So both of them are 1.8, 0.4. So I can multiply by 10. So if I multiply by 10, it become a whole number. 18 is to 4 directly. And then 18 over 4, there's a common factor of 2 divided by 2 gives you 9 is to 2. Okay, have you gotten the method? But next one, part D. Now we have two quantities, but the units of these quantities are not the same. One is 35 cents, the other one is $2. How do you think I should change this number such that they will have the same units? Well, I can change everything into dollars, then I'll probably get decimal places. Or I can change everything into cents also. So in this case, I'm going to keep 35 cents. And $2, $1 got how many cents? 100 cents. So 200 cents. So I can divide both sides by 5. Okay, or I can use my calculator, right? 35 over 200. So 35 over 200 simplifies to give me 7 over 40. So this means this ratio will be 7 over 40. So, or what you can do, you divide by 5 throughout to give you the answer. Okay, let us choose two more questions. Okay, and then you can try to complete the rest on your own. Right, maybe let's choose part G now and part H, because part H involves 3 ratio. Now 35 minutes is to 2 hours. How can I convert this? Will you want all the units to be in terms of minutes or in terms of hours? Well, it'll be easier to change everything into minutes. So this will have 35 minutes. And that will give you 2 hours times 60 will give you 120 minutes. Now you notice that the moment I change the units on both sides to remain the same, I drop away the units. So a ratio does not have units itself. Okay, then now I'm going to use 35 over 120, and that gives me 7 over 24. That means 35 divided by 5 will give you 7. 120 divided by 5 will give you 24. So this will be the ratio in the simplest form. Now trouble comes for part H. When it's 2 numbers, I can still use the fraction in my calculator to help me to simplify, right? But now we don't have the luxury of doing that because it's 3 terms. So we need to consider the common factors across all 3 of them. But first, it all comes in different manner. One is some of them are decimal, some is in fraction form. So what can I do? I can actually try to convert this into decimal first. Let's take a look at what this number is. This is actually 2.25 is to 1.5. Now 2.25 has 2 decimal places. In that case, I need to times 10 times another 10. That means I need to times 100 times 100 times 100 throughout the whole ratio to get rid of decimal places. So if that's the case, I'll get 60 is to 225 is to 150. Now let's try to simplify all this so I can divide by 5. So 60 divided by 5 will give me the number 12. 225 divided by 5, I'm sure it can be divided. This will be 45. And then 150 divided by 5, that will give me 30. But is this the simplest form? I check with the factor 2, no, don't have. I check with factor 5 according instincts. Now, notice 12, 45, and 30, they're all multiples of 3. So I can further simplify to be divided by 3, and that gives me 4. 45 divided by 3 will give me 15. 30 divided by 3 will give me 10. And that will be the answer. Now I'm going to move on to the next part of the example. So I'm going to leave you to do these two questions, E and F, on your own. Alright, now let's move on. Example 2. Now this is our next part of skill where we try to relate ratio to fractions, and then we try to use this ratio concept to solve problems, right? So now let's begin. The first one question over here, example 2. $248 is divided among 3 girls. So I got half, 1/5, and 1/3. Now there are some students who will tell me, oh, the 1/, stays all the same throughout. Then my ratio now become 2:5:3. Is that true? No, that's not true, right? So what I'm going to do now is, how am I going to express these in terms of its lower terms as a ratio? First thing, ratio needs to have, can be only in terms of whole numbers. Now I notice I have the denominator 2, 5, and 3. What is the LCM for 2, 5, and 3? LCM for 2 and 5 is 10. Then 3 will be 30. So in this case, what I can do is, I'm going to multiply 30 to each and every one of the ratio such that it becomes a whole number. Half times 30 will give you 15. 1/5 times 30 will give you 6. 1/3 times 30 will give you 10. Okay, and let's check, is there any more common factors over here? Don't have. So therefore, this is all in integers. This will be my ratio. Now moving on to part B. Now that we have the ratio, and this amount of money, $248, is being shared among all these units, right? So find the amount of largest share. Before I find the amount of largest share, how many units are there in total? I have 15, 6, and 10. So the total number of units will be 31 units. So how do you get the number? You add everything together, isn't it? So we will have part B, our answer. Now I'll request the following presentation to be done properly. 31 units represent. Please do not use the equal sign. Okay, 31 units is not equal to $248 technically, because 31 units have no units, but $248 have a unit to it, and the unit is dollars. So they are not equal to each other. But we can say that 31 units represents $248. In order to find the amount of largest share, now what some students will do, even before they do this, they will try to tell me that, oh, child, I can find the 1 unit. Right? So some student will find 1 unit for this. If you are comfortable with that, go ahead, no problem. Just that you might need to spend a little bit more time on this. So in order to, 31 units represent 248, 1 unit will have how much? I'll need to divide by 31. And that gives me $8. Now they want to get the largest share. The largest share is the number 15 units, right? So what you can do is you take 8 times 15. So you divide by 31, then after that you times 15, or whichever. So now what I can do is, instead of using this method, okay, what I'll need to do is I'll take 28 8248 and 31 and 15, I will do this method. 15 units out of 31 units times 240. That means I write it as a fraction. I want 15 units out of 31 units of $248. And then if this is the case, I'll skip this working over here and get to the answer directly. So 15 over 31 times 248. And that gives me the answer 120. Is this same as the answer that you have written? Now question C, find the amount of the larger share. I've given the units or whichever, and I'm writing it as representation, so I can leave this as my final answer. So have you gotten the answer? Let's try a few more examples. Now I'm given x is to y and then x is to z. Oh my god, there's so many numbers. So first of all, x is to y. I will do them one by one. 1 1/4, 2 over 3. What is in the denominator? Denominator 4 and 3. What's the LCM, lowest common multiple of 4 and 3? 12, right? So what can we do to make this into whole numbers without the fraction? We can multiply by 12, multiply by 12 to each of the ratio. So 1 1/4 times 12, that gives me the number 15. And then 2 over 3 times 12 will give me the number 8. So I have gotten this x is to y in terms of two numbers, whole numbers itself. Next one, at the same time, they tell me x is to z is given by 1 and 3 over 7, 5 over 6. Can you tell me how to get rid of the denominator and change it into integers? Well, I can have times, this is 7, this is 6. So what's the LCM for 7 and 6? I'll take 42, right? So I'm going to multiply by 42 and multiply by 42 throughout to each of the ratio. So for this, after I multiply by 2, I get 60. Oh no. Is to 35. Okay, so now let's try to combine these two fractions together. X is to y is to z. The first one, I got 15, x is to y, 15 is to 8. And then for x is to z, that will be 60 is to 35. Now we notice that these two are not the same units. We cannot compare them. So what I can do is I try to make them into the same lowest common multiple. But well, 60 can be divided by 15. So what I can do, 60 divided by 15 is actually 4. So for 15, I need to times 4. If I times 4 to x, at the same time, I need to multiply by 4 to y so that they have the same quantity for comparison. So now changing this, I will get 15 and 60 to be the same ratio, 60. And now y changed into 32 units and z is 35 as usual. So now everyone is an integer. This will be the solution. Now I'll leave you to do some of the practice questions on your own. So example 4 will be under homework or offline assignment. Okay, same for example 5, 6 and 7. So this one here and here. You should be able to do these questions on your own. Now, after you have completed these few questions on this page, please take a photo of it and submit to me on Google Classroom under assignment. Now, before we end off our lessons for this next part, we're going to look at our example 8, 9, and 10. So slightly a little bit harder questions, okay, to practice. Okay, now first one on word problems, the ratio of Anna to saving to Bobby's saving. So let me write down the ratio first. I'll denote A for Anna, B for Bobby, and the ratio of Carol's saving so is to C, okay? So ratio of Anna to Bobby is 3:8. Carol's savings, okay, to Bobby's saving. Carol's saving. So Carol is 11. Bobby's saving is 4. Okay, but before we try to do the other questions, we notice that these two units are for Bobby are not the same, not on common ground. So what we can do is we need to try to make them common. So in this case, 8 and 4, what's the lowest common multiple? Well, it would be 8, right? So I'm going to multiply by 2 to 4. If I multiply it to B, I also need to multiply it to C in this case because it's Carol's one. So everything multiplied by 2, I'll get my ratio to be for A is to B is to C is 3 is to 8 is to 22. Right? So we're going to use this ratio for the working. Question says if the difference, what do you mean by difference? That means taking big minus small, right? The larger number minus the smaller number. Between Anna and Carol's. So Anna has 3 units, Carol has 22. So what's the difference? Well, I take 22 minus 3, isn't it? 22 minus 3, that gives me the difference of 19. Okay, so now that means 19 units. They say is so much, right? The difference between them is so. But this, remember, is not an equal because 19 units have no units. But the other one is on dollar. It has a particular unit. So both of them are not the same. So 19 units represent $608. Find the amount of Bobby's saving. So Bobby's saving has 8 units. So in this case, I'm not going to find 1 unit first and then 8 units. I'm going to find 8 units directly. Okay, so actually this is like a fraction, right? So 8 out of a total of 19 multiplied by $608. So 8 over 19 times 608. And that gives you the answer $256. Have you gotten the answer? Okay, if you're ready, let's move on to question number 9. Now, question number 9 here says, Senior Citizen Club has 98 members. So, and the ratio of men is to women. Oh, so the 98 members, is it men or women? No, it's both of them, right? Both men and women. So, if ratio of men is to women is 5 is to 9. Okay. After 22 new members joined the group, the ratio of men to women became 9 is to 11. Oh, before and after, right? So, how many men joined the club? Okay, now let's take a look at the total. So now if we have a total of origin is 98 members. Now this one over here has 5 units and 9 units. The total is 98 members. So how do we get the total number of units? That would be 5 plus 9, which gives you 14. So we know that 14 units represent, not equal, okay, not equal, 98 members. One has no units, the other one is just members, right? So find after 22 new members join the club, the ratio, they want to find how many men, right, join the club. So we're going to look at men. Men have how many units? 5, right? So I'm going to find 5 units. And 5 units will be 5 out of a total of 14 times 98. And that is actually representing 5 over 14 times 98 to give me a number of 35 members. Now, if you're able to do this calculation on your own without, you can actually write down the answer directly without writing the working in this case. So I have originally 35 male members. Okay. Now that 22 new members joined, my total will change from original 98 plus another 22. So 98 plus 22 will give me a total of 120. I'm looking for a new ratio. Now the new ratio is 9 is to 11 for man is to woman. So 9 is to 11 and you have a total of 20 units. So in this case 20 units represent 120 members. Correct? How many men join the club? So they are actually looking for the men. The ratio with the men is 9, right? So I'm going to find 9 units now. The before and the after. How do we do this? We take 9 out of a total of 20 times 120. So 9 over 20 times 120. I'm not going to write the working. I'm going to write the answer straight away. 54 male members now. So before that it was 35. Now after this is 54. So how many men joined the club? So number of men. Write a quick description. 54 minus 35 to give me 19 men. Okay, I'll go through the last example for the day before I leave you to do the working for the rest of the answers. So now example number 10. Given that 2x equals to 3y, find the ratio of x is to y. Now this one that is shortcuts and conceptual understanding. So now what I'm going to do for you is I'm going to show you the conceptual understanding. Okay, now in this part of the chapter they says that 2x is equals to 3y. So actually 2 units of x is equivalent to 3 units of y. Which number, x or y, has a larger quantity, larger number of units? Well, x is larger, isn't it? So the shortcut actually is x will be 3 units and y will be 2 units. So if you read this directly, x is to y will have x to be 3 and y to be 2. Okay, but I can also explain this in terms of algebra method. So 2x is equals to 3y. Let's recall that ratio can be written in the form of a fraction. So if I want to have 2x to be equals to 3y and I want to find the ratio of x is to y, that means I'm actually looking for the ratio x over y. So I'm going to manipulate this one over here until I get x over y. So down here, firstly, I'm going to keep 2x. I don't want y to stay in here. This is 3 times y. So I've divided by y on both sides. And I'm left with the number 3. Next, I don't want the number 2 to be down here. So I'm going to divide by 2. If I divide by 2, this one will be left with x over y. And this one, 3, needs to be divided by 2. So that tells me x is 3 units, y is 2 units. So x is to y is still 3 is to 2. If that's the case and you have understood it, please do example 11. You may use the shortcut or you can also use the algebra method. We shall stop here for the day and see you next lesson.